Hello, welcome to another module in this massive open online course. So, we are looking at the Laplace transform and the properties and applications of Laplace transform. Let us now look at example problems to better understand the Laplace transform. Okay. So, what we want to now do in this module and also probably the next few modules is look at example problems for the properties and application of the Laplace transform. Okay. And so, let us look at example problem number 1. Let us start with something simple. So, I have a signal x t equals e raised to 2t u t, where u t is the unit step function, plus e raised to minus 3 u minus t. Now, we want to compute the Laplace transform or evaluate the Laplace transform of this signal, correct. So, we want to evaluate the Laplace transform of e raised to 2t u t plus e raised to minus 3t u minus 3. And we also want to find the ROC. Of course, the Laplace transform is incomplete without the ROC. So, now we will use the following properties. We already know that the Laplace transform of e raised to minus a t u t, this is 1 over s plus a, and ROC is real part of s greater than minus a, and the Laplace transform of minus e raised to the power of minus e raised to minus a t u minus t is also equals 1 over s plus a, but the ROC equals real part of s less than minus a. Okay. And therefore, now if you look at this signal e raised to 2t u t, this is equal to e raised to minus a t u t, a equals minus 2. Okay. So, implies the Laplace transform of this signal can be obtained as 1 over s plus a, where a equals minus 2, which means the Laplace transform is 1 over minus 2, the ROC is real part of s greater than minus a, that is real part of s greater than real part of s greater than minus a, that is real part of s greater than 2. On the other hand, let us look at the other signal, that is e raised to minus 3t u minus t, which is equal to e raised to minus a t with s equals with a equals e raised to minus a t with a equals 3. So, the Laplace transform is 1 over s plus 3, the real part of s greater than or real part of s less than, because this is a left handed signal. Remember, u minus t is equal to 0 for t greater than 0, therefore, this is a left handed signal. So, the region of convergence is of the form ROC, that is real part of s is less than something. So, here the ROC is of the form real part of s is less than minus 3, ROC is less than minus a equals 3 here, and therefore, ROC is real part of s less than minus 3. Now, you see the net ROC of the signal will be the intersection of these two ROCs. Therefore, the net ROC equals real part of s greater than 2 intersection with real part of s less than minus 3, and you can see that the intersection of these two signals, there is real part of s greater than 2 and real part of s less than minus 3 is basically 5. There is an empty set. There is no value of s where both the Laplace transform of both these signals, that is e raised to 2t ut and e raised to minus 3t u minus 3 converge, and therefore, correct, e raised to 2t ut and e raised to minus 3t u minus t converge, and therefore, which implies that the ROC is the empty set, which means that the Laplace transform of this signal does not exist. Okay. So, this intersection, correct, this intersection equals phi, which is basically empty set, correct, this is the empty set. Implies basically ROCs do not overlap implies that Laplace transform does not, the Laplace transform XS does not exist for this signal. Let us look at another example. For instance, the same thing, let us now look at the signal, just modify that a little bit. Let us now look at the signal x t equals e raised to minus 3t ut plus e raised to 2t u minus t. Now, the Laplace transform of e raised to minus 3t ut is 1 over, now this is e raised to minus at ut with a equal to 3. So, this is 1 over s plus 3, ROC is real part of s greater than real part of s. This is a right handed signal because ut is basically 0 for t less than 0. So, this is a right handed signal. So, ROC is of the form real part of s greater than minus 3, real part of s greater than minus a equal to 3, and e raised to 2t u minus t, this is a left handed signal with basically with Laplace transform. I think here e raised to minus 3t, the Laplace transform is minus 1 over s plus 3. Okay. So, I will just correct this, this is minus 1 over s plus 3. Okay. And therefore, the Laplace transform e raised to 2t u minus t is basically minus e raised to 2t u minus t is minus 1 over s plus a is minus 2. So, this is 1 over s minus 2 and minus 1 over s minus 2, and the ROC is real part of s basically real part of s less than minus minus a, that is real part of s less than. So, this corresponds to a equals minus 2, this corresponds to a equals 3. So, real part of s less than minus a, which means real part of s less than 2, which implies the net ROC equals the intersection of these two ROCs, that is real part of s greater than minus 3 intersection real part of s less than 2, which is equal to, well, this is equal to minus 3. You can clearly see intersection is minus 3 less than real part of s less than 2, and the net Laplace transform XS equals 1 over s plus 3 minus 1 over s minus 2. So, therefore, XS is equal to, well, s minus 2 minus s minus 3, that is minus 5 divided by s plus 3 into s minus 2, and the ROC for this is minus 3 less than real part of s less than 2, that is the corresponding ROC, region of convergence for this Laplace transform. So, the Laplace transform is minus 5 over s plus 3 into s minus through s minus 2, and the corresponding ROC is minus 3 less than real part of s less than 2. Okay, all right. Now, let us look at another example. This is example number, the second example problem to understand how to evaluate the Laplace transform. So, I have x t equals e raised to minus 2 t u t minus u t minus 5. This is equal to, now let us look at this. Let me simply write this as e raised to minus 2 t u t minus e raised to minus 2 t u t minus 5. Now, e raised to minus 2 t u t, this has the Laplace transform, this is a right handed signal. So, this has the Laplace transform, well, a equals, this is e raised to minus a t u t with a equal to 2. So, this is of has the Laplace transform 1 over s plus 2, and the ROC is of the form real part of s greater than minus 2, because this is a right handed signal. Now, consider this signal e raised to minus 2 t u t minus 5. Now, this can be equivalently written as, this signal can be equivalently written as e raised to minus 2 t minus 5, correct, e raised to minus 2 t minus 5 times e raised to minus 10 into u t minus 5, which is e raised to minus 10 into e raised to minus 2 t minus 5 into u t minus 5. Now, if you look at this signal e raised to minus 2 t minus 5 u t minus 5, this is of the form x t minus t naught, where t naught equals 5, correct, and x t is e raised to minus 2 t into u t. So, this is x t, this is a signal x, this is a signal x t delayed, this is a signal x t where x t is e raised to minus 2 t u t delayed by t naught, where t naught equals 5. Hence, we know that the Laplace transform x t minus t naught is e raised to minus s t naught into x s. Therefore, the Laplace transform of this will be, well, first we have the constant e raised to minus 10 into e raised to minus s t naught is 5. So, this will be e raised to minus 5 s divided by into 1 over s plus 2, which is the Laplace transform of e raised to 2 minus 2 t u t, and the ROC will be again real part of s greater than minus 2. Therefore, the final Laplace transform will be, that is x s will be the sum of the two Laplace transforms 1 over s plus 2 plus e raised to minus 10 e raised to minus 5 s divided by s plus 2, which is equal to 1 over s plus 2, I am sorry, this will be a minus 1 minus e raised to minus 5 into s plus 2, and the ROC will be real part of s greater than minus 2. This is the final region of convergence for this problem. Okay. This is the ROC for this problem. Okay. Now, let us do another example. We want to evaluate the Laplace transform of the following function, that is L t of e to the e raised to minus a t cosine omega naught t ut. And remember, we already know that the Laplace transform of cosine omega naught t ut is s divided by s square plus omega naught square. Okay. So, we already know that the Laplace transform of cosine omega naught t ut is s divided by s square plus omega naught square, and the ROC for this will be, or ROC for this is that the real part of s is greater than 0. This is a right handed signal. Now, remember, we have the property, recall we have the property e raised to minus a t x t has the Laplace transform x of s plus x of s plus a, correct. So, where x s is the Laplace transform, that is, if x t has the Laplace transform x s, correct, then e raised to minus a t x t as a Laplace transform x plus x s plus a. Therefore, e raised to minus a t cosine omega naught t u t will naturally have the Laplace transform s plus a, that is replace s by s plus a whole square plus omega naught square. And the region of convergence will be, naturally region of convergence will be real part of s plus a greater than 0. Real part of s implies real part of s greater than minus a. This is the region of. So, this is the Laplace transform, that is x s, and this is the region of convergence, that is real part of s is greater than minus a. The Laplace transform is x of s plus a, that is s plus a divided by s plus a whole square plus omega naught square. Okay. All right. Let us now do another problem. We have the Laplace transform equals, given the Laplace transform x s equals 3s plus 4 divided by s square plus 3s plus 2, the ROC is real part of s less than minus 2. Okay. Now, we want to evaluate the inverse Laplace transform. That is, what is the signal x t. Now, the inverse Laplace, now we want to evaluate the inverse Laplace transform, that is corresponding to x s, the given Laplace transform, the Laplace transform x s, we want to find the what is the inverse Laplace transform, that is we want to reconstruct the corresponding signal x t. Now, observe first that this is a rational function. That is, it is a numerator polynomial divided by denominator polynomial. Further, degree of numerator polynomial is 1, degree of denominator polynomial is 2. Therefore, we have m less than n, which implies is a proper rational function. Therefore, I express this as partial fractions. Now, if you look at this, I can write x s as 3s plus 4 I am sorry 3s plus, let me just change this slightly, this is 3s plus 5. So, I can write x s as 3s plus 5 divided by s square plus 3s plus 2. The roots are minus 2 and minus 1. So, I can write this as s plus 2. Remember, the factors are s plus 2 and s plus 1. So, I can write this as plus 2 and s plus 1, and therefore, now the poles P 1 equals minus 2, P 2 equals minus 1. In fact, 0 minus 5 by 3, 3s plus y equal to 0. So, the 0 is minus 5 by 3. So, these are the poles, correct. These are the poles of the rational transfer function. Therefore, I can express using partial fractions Therefore, using the partial fraction expansion, I can write xs equals C1 some constant C1 divided by s plus 2 plus some constant C2 divided by s plus 1. Now, the way to evaluate C1 we already know this is, well, s plus 2, that is s minus P1 times xs evaluated at s equal to P1 evaluated at s equal to minus 2, which is x plus s plus 2 into xs is 3s plus 5 divided by s plus 2 evaluated at s equal to 3s plus 5 divided by s plus 1 evaluated at s equal to minus 2, that is minus 1 divided by minus 1, which is equal to 1. Therefore, C1 is equal to 1. You can see that C1 is equal to 1. The coefficient C1 corresponding to the pole P1 equals minus 2. Partial fraction expansion of xs is C1 equals 1. Okay. Now, C2 similarly can be evaluated in a similar fashion. One can evaluate C2 as s plus 1 into xs evaluated at s equal to minus 1, s plus 1 into xs. Now, you can see this is equal to 3s plus 5 divided by s plus 2, that is evaluated at s equal to minus 1, which is basically 2 divided by 1, which is equal to 2. Okay. And therefore, C2 equal to 2, and therefore, from the partial fraction expansion we have xs equals 1 over s plus 2 plus 2 over s plus 1. Now, you can see the ROC is real part of s less than minus 2, which basically implies that this is a left handed signal. Okay. When ROC is of the form real part of s less than sigma max, this is a so this will be of the form minus e raised to minus 2t u minus t. This is of the form, that is the time domain signal corresponding to 2 over s plus 1 is minus 2 e raised to minus t u minus t. Therefore, net signal x of t will be minus e raised to minus t or let me just write it clearly, x t is minus e raised to minus t u minus t minus 2 e minus t u minus t, and that is the net. So, that is the net time domain signal or the inverse Laplace. So, that is the inverse Laplace transform. that is the expression for the inverse Laplace transform. So, all right, in this module we have seen some examples, example problems for the Laplace transform, how to evaluate the Laplace transform as well as the inverse Laplace transform. We will continue looking at these examples, other examples in the subsequent modules. Thank you very much.